The first lunar roving vehicle was used in the Apollo program in 1971. This configuration was based on work by Mieczysław Gregory Becker. Mieczysław Becker was born in Poland and graduated from Warsaw Technical University in 1929. In 1942, he accepted an offer from the Government of Canada to move to Ottawa to work on armored vehicle research. He joined the Canadian Army in 1943 as a researcher and reached the rank of Lieutenant Colonel. In 1956, he moved to the United States. Mr. Becker's engineering achievement was acknowledged in a special diploma which reads, "In recognition of outstanding scientific contributions to the Lunar Roving Vehicle Program, his leadership and pioneering efforts in the development of a methodology of the mechanics of off-road locomotion, the conduct of research on the physical characteristic of the lunar surface, and the evaluation of locomotion concept later culminated in the highly successful development of the lunar roving vehicle, the first manned vehicle on the moon. The outstanding performance of the rover provided a greatly increased range of exploration, significantly increasing the scientific accomplishments of Apollo missions 15, 16, and 17. At the present time in Montreal, Mr. Krzysztof Skonieczny, assistant professor at Concordia University, is conducting his own research related to the newest Mars rover vehicle. His busy schedule includes the newest wheel testing at Concordia Laboratory. A new Mars rover, slated to launch in 2020, may well incorporate a Concordia University wheel design. To understand the complexity of Mars' environment, Krzysztof Skonieczny took flights over Ottawa in March 2018 to recreate the gravity of Mars. Gravity simulation in flight was achieved by special maneuvers conducted by the pilot for the purpose of reaching the target gravity. Krzysztof Skonieczny says, "I'm not shy with my excitement about the cool things we get to learn." Canadian involvement in space exploration is recognized by the famous Canadarm. The first Canadarm-1 was installed on shuttles. Witold Krzywiecki, through his aerospace work applications and projects as a senior stress engineer, was involved in the Canadarm-2 project. The new Canadarm-2 is installed directly on the space station, performing flawlessly very complicated tasks. Witold Krzywiecki provided stress and structural analyses of the Space Orbiter Shuttle and space station robotic structures. He was also involved in design approval and development of flight components of the Space Shuttle robotic arm. Witold Krzywiecki was involved in the engineering of the space station robotic arm and special purpose dexterous manipulator. For his work, he was recognized by NASA's Profound Appreciation Diploma. Aerospace manufacturing is a major industry in Canada. One of the biggest is Cyclone Manufacturing in Mississauga, Ontario. Cyclone Manufacturing was founded in 1964 and engaged in aerospace in 1978. Cyclone Manufacturing is privately owned and operated by Andrew Sohai since 1990. Vertically integrated machining, fabrication, assembly, and processing. Original equipment manufacturing approvals with Airbus, Bombardier, Boeing, Embraer, Lockheed Martin, IAI. 5 facilities, 400,000 square feet, or 37,000 square meters in Canada and Poland. 110 CNC machining centers, including 55 of 5-axis. 750 total employees. Total revenue for 2017 was $98,250,000 Canadian. Cyclone Manufacturing specializes in manufacturing of small to large structural aerospace components and assemblies such as wing structures, flight control surfaces, aerostructures, and assemblies. The company timeline. Starting with one computer numeric controlled machine in 1981, the company expanded to over 100 of these machines in 5 manufacturing locations. Cyclone Manufacturing is in the top 1% of the largest privately owned aerospace companies in North America. The owner of Cyclone Manufacturing, Polish immigrant Andrew Sochaj, and his wife immigrated to Canada from Poland in the late 70s. And he began working at Cyclone when he started his work there. From his humble beginnings, he quickly became highly regarded as an excellent employee, establishing the base of operations and directing several projects for his superiors. Through hard work and dedication, in 1990, Andrew acquired full shares of Cyclone Manufacturing, and over the years grew this entity from a 24,000 square foot facility to over 400,000 square feet, working alongside and developing long-term relationships with world-renowned aerospace OEMs, original equipment manufacturers. Never satisfied with the status quo, Andrew Sochaj continues today to lead company development through innovation and leadership. He is a graduate of the University of Lublin, Poland, and holds a Bachelor of Engineering degree. As a community leader and a patron of the arts, he is involved in community services. Mr. Sochaj, a proud father of 2 and grandfather of 5, has a strong belief in mentoring the younger generation to succeed. Cyclone's facilities reached over 400,000 square feet in 5 global manufacturing facilities located in Mississauga, Milton, Meadowpine, and Kraśnik, Poland. The latest manufacturing plant in Poland marked the international expansion of the company. Now, getting back to Earth and some Canadian history of engineering. This is the Quebec Bridge. In 1900, construction began on the Quebec Bridge, which linked Winnipeg to Moncton on the National Transcontinental Railway. As construction neared completion, it collapsed under the weight of a locomotive loaded with steel. 75 people were killed, and a subsequent inquiry showed the accident was due to an error in judgment by the engineers who designed the bridge. Tragedy struck again during the second attempt to build the bridge in 1916. The center span collapsed while being hoisted into place, killing 10 more people. The bridge was eventually rebuilt thanks to a Polish engineer, Ralph Modjeski. Ralph Modjeski was a Polish civil engineer who achieved prominence as a preeminent bridge designer. He took over the misdesigned Quebec Bridge after the 1907 disaster that killed 75 workers, and succeeded in creating the longest truss span in the world in 1917. It is still the longest cantilever bridge in the world. The bridge was finally completed in 1917. The main span is 549 meters, or 1,800 feet in length. As for current engineering notables, there are a number of scientists like Ms. Maria Marianna Polak, Professor of Civil and Environmental Engineering at the University of Waterloo, who earned her PhD at the University of Toronto and Bachelor and Master of Science degrees at Krakow University in Poland. Marianna's interest is in structural mechanics, structural concrete, and assessment of deteriorated infrastructure. Her other interests include the durability of polymers and polymer composites, as shown on the picture of a destructive test stand. The non-destructive detection of damage in concrete is conducted during laboratory tests. Maria Marianna Polak was a visiting professor in Germany and Poland. She contributed to the development of North American and European design standards. She is also the author of over 200 technical publications. For subway enthusiasts, Jarosław Skonieczny, manager of subway vehicle engineering, shares his knowledge of the Toronto Transit Commission. The subway map of Toronto is very impressive, creating no small feelings of envy for people living in Ottawa. The numbers for Toronto Transit Commission are very impressive. Daily ridership over 2.7 million, in which 1.4 million go by bus, 271,000 by streetcar, 46,400 by intermediate rail, and over 1 million by subway. Lost articles. The Lost Articles team works tirelessly to reunite more than 4,000 items at any given time with their owners. So visit Toronto. Ride for your pleasure, says Skonieczny manager, Subway Vehicle Engineering at Toronto Transit Commission. Let's check some engineers in Ottawa. Wojciech Remisz is president of Remisz Consulting Engineers Limited. He is founder and principal of the firm, a designated consulting engineer since 1992, with over 40 years of extensive work experience. He is licensed as Quality Verification Engineer by the Ministry of Transportation. His company was involved in the rehabilitation of Ivy Lee Bridge at Thousand Islands Customs border crossing, providing structural reinforcement utilizing the super innovative suspended working platform. A very challenging project in his career was the Rockcliffe Parkway Recreational Pathway, as seen under construction. This project is unconventional, with a unique structural system providing technical innovation and excellence. Consequently, Remish's company was recognized with the Willie Chipman Award in recognition of the project that best demonstrates the contribution of consulting engineering to the social, economic, and environmental well-being of Ontario. The current project, in collaboration with other companies, is the creation of rail links within the Ottawa region known as Moose Project. When completed, it will provide much-needed connectivity between rural communities and the urban Ottawa-Gatineau region. Nuclear energy is a very fascinating subject. Nuclear power stations provide electricity for all of us. Nuclear energy is used to heat water to create steam, which turns the turbines connected to a generator. Nuclear power stations do not produce any carbon dioxide, as do coal and gas-fed power stations. What is often mistaken for fumes is only water vapor generated by these cooling towers. One of the nuclear specialists is Stefan Baginski, with past and present membership in many engineering associations. Baginski Engineering Limited offered a completely new solution for much-needed maintenance that saved over $250 million per reactor, resulting in total savings for the Pickering Nuclear Power Plant of $2 billion in 1981 dollars. Dr. Baginski proposed extremely mobile robots climbing between pressure tubes in very restricted spaces. The moving robot provides structural support for tools that were cutting the pressure tube and re-welding it back again. This operation was filmed for the Federal Safety Regulator, who issued the operational license based on records of work performed. The testing facility at Bruce Power Station. This picture shows the reactor mock-up designed by Stefan Baginski. It was necessary to test Baginski's equipment on a reactor mock-up because the real reactor would contaminate his invention during tests. The testing facility at Bruce Power Station. This picture shows Stefan Baginski with the reactor mock-up, robots, and controls. Project manager and architect Václav Kujbida. He managed over 54 large projects with a total budget of $165 million Canadian for the Public Works and Government Services Canada and also for Indian and Northern Affairs Canada, presently Indigenous and Northern Affairs Canada, mostly on Aboriginal lands and territories. Nunavut Infrastructure Project includes housing in Pangnirtung, Iqaluit, which is located on the right side of the map. This map includes places of infrastructural activities. The Government of Nunavut office building in Pangnirtung. To get to all locations in the north, it was necessary to fly by plane because of great distances and the lack of roads. This picture was taken on Cape Dorset, Nunavut in October 2000. It shows the Nunavut Infrastructural Project team ready for the next site inspection stop. If you wonder who designed the National Arts Centre in Ottawa, the answer is Polish-born architect Fred Levensold. NAC was built between 1965 and 1969 and was later designated as a National Historic Site of Canada. As you have just seen, engineering is a fascinating way of life. Thank you for your attention.